Alright, we are going to start off with tutorial 1 and question 5. In tutorial question 5, you are given the equation of a plane, and then you want to check whether or not this point A is on this plane. And how do you go about it? What you're going to do is you are going to put this point into the R here. So this is the left hand side. 9, 2, 6 dot with 1, 2, minus 2. Alright, so you do your arithmetic of 9, 2, 6 dot with 1, 2, minus 2. 9 plus 4, 13 minus 12 gives you a value of 1. Because these two numbers tally, so I can therefore conclude that the point A lies in pi. Alright, that's how you should check that the point A lies in the plane pi. Then part 2, you now have a point B. The point B is 2 minus 5, 6. So you want to show that this point B does not lie in the plane pi. So what you do is, again, you do left hand side. 2 minus 5, 6 dot with 1, 2 minus 2. This gives me 2 minus 10, so it's minus 8. Minus 8 minus 12 is minus 20. So this is not equals to 1. So because this value isn't 1, that means this value is not the number on the right. So therefore you can say that B is not in pi, not in plane pi. Alright. Then because the point B is not in the plane pi, it now makes sense to find the distance from point B. Okay, continuation. Distance from B to the plane pi. Right. So because the point B doesn't lie in the plane pi, we now want to find the distance from the point B to the plane pi. How do we do so? The distance can be found by taking the point in question. In this case, it's the point B. 2 minus 5, 6. You dot with the 1, 2 minus 2. Then you take the point in question minus the normal vector of the plane. Sorry, you take this point in question, dot with the point, with the direction vector of the plane, and then you minus away this 1. Minus 1, and then you divide by, you divide by the magnitude of the normal vector of the plane. So you divide by square root of 1 square plus 2 square plus minus 2 square. This is how you find the distance from a point to a plane. How do you go about it again? We have discussed this in the notes, and we have learned that the way to do it is to take the point in question, dot product with the normal vector, then you minus away the right hand side, and then divide it by the magnitude of the normal vector. So let's perform this calculation. The numerator will result in 21, whereas the denominator will result in 3. So the distance is 7. In part 3, you are now asked to find you are given a point C. In part 3, right? In part 3, you are given a point C, and C has this coordinates 2009, 7, M, and you know that the distance from this point to the plane pi is 26. And now in this case, you want to find the value of M. So we do the same thing. We're going to do the same thing. Take the point in question. Dot product with the normal vector of the plane. 1, 2, minus 2, minus 1, divided by the magnitude of this vector, which is 3. You equate this to, you are told that the distance is 26. 26. Right. So let me work out the numerator. Okay. For the numerator, I'm going to get 2009 plus 14. Okay, I got the modulus of 2022 minus 2m. I bring a 3 across, 60, 78. Right. Okay, let me just double check again my calculation. I take 2009 Alright, then from there you're supposed to solve for the value of m. So how to solve this equation? Okay, let me do it here. Let me do this question, continue here. So from here, because this is a modulus, right? Because modulus, I have to say that this is equals to plus minus 78. Right? It can be either a plus 78 or a minus 78. So if you were to solve it further, you get m equals to 972, or m is equals to 1050. I guess the number 1050. Right, this is actually part 3 of number 5. And then in part 4, you're asked to find the foot of perpendicular from the point D, to the plane. So in part 4, you want to find the foot of perpendicular from a point D to the plane. This is the plane pi. This is the point D. This is origin O. This is the foot of perpendicular. So you want to find the foot of perpendicular, means you want to find this vector. This vector is what you want to find. Right? You're given the vector OD. OD is given to you. Right? OD is given to you. Okay? Now, judging from this diagram, I can always say that OF, that the vector OF, right? The vector OF is equals to the vector OF, which is what you want to find, okay? The vector OF is equals to OD plus DF. And OD is equals to 47 minus 5. Right, then looking at DF, right? DF, if you look more carefully, DF is actually perpendicular to the plane. So therefore, DF will be parallel to the normal of the plane. DF will be actually parallel to the normal vector of the plane. So I can say that this is equals to a multiple of the normal vector of the plane pi, which is 1, 2, 1, 2, minus 2. Alright? So the starting point to find the foot of perpendicular is always to express the vector OF in terms of OD plus lambda of the normal vector of the plane. And then because the point F is on the plane, I can then say that OF, right, this OF, which is 4 plus lambda, 7 plus 2 lambda, minus 5 minus 2 lambda. OF must satisfy the equation of the plane. So OF dot with 1, 2 minus 2. 1, 2 minus 2 must be equals to 1. So you'll solve this equation. To solve the equation, what I can do is I'll take the numbers, dot product with this first. So it's 4 plus 14, 18. 18 plus 10 is 28. Okay, you get 28. Then next one is 9 lambda plus 9 lambda is equals to 1. So this means lambda is equals to minus 3. Right, lambda is minus 3. So if lambda is minus 3, then if you ask for coordinates, right? Coordinates means you write this now. The coordinates on the point F will therefore be, you put lambda as minus 3 into here, right? Into here. So you are going to get 1, 1, 1. Right. This is the foot of a perpendicular from the point D to the plane. And that completes question 5 of tutorial 1. Now into question 6 of tutorial 1. In question 6 of tutorial 1, you are given an equation of a line and an equation of a plane. In part 1 of the question, it says that if m is 3, so if n is 3, this point will be known as 3 minus 1, 0. Right? So if m is 3, you want to show that this line L lies on the plane. So how am I going to do it? I'm going to do this in 2 steps. Okay. Firstly, I will show that the line L is parallel to the plane pi. So I'm going to do this now. Line L is parallel to the plane pi because, okay, to check that a line is parallel to a plane, you want to imagine that if this is a plane and this is a line, right? This is a line and this is a plane. If a line is parallel to a plane, what you will see is the directional vector of the line and the normal of the plane, they will be perpendicular. So what I do to check is that I will take the directional vector of the line, which is 2 minus 2, 1, dot with the normal vector of the plane, and let's see what you get. You will get 2 minus 4 plus 2, and that gives you 0. So that confirms that the line is parallel to the plane. Then the next thing that I'm going to do is, I will want to demonstrate that this point on the line, right, this point on the line, which point in this case? In this case, this point is the vector 3 minus 1, 0. I want to show that this point 3 minus 1, 0 is on the plane. How do I show it? I will take 3 minus 1, 0 to dot product with 1, 2, 2. When I perform this dot product, I hope to get to the same thing as the right hand side here. So let's see the dot product. You get 3 minus 2 plus 0, and this is 1. And this number actually tallies with this number. So affirming that the point, so this means the point 3 minus 1, 0 lies in the plane pi. So by the first two set, by 1 and 2, L lies in pi. Why is that so? If this line is parallel to this plane, and this point on this line is also on this plane, then the line ought to be right here. The line ought to be right here, where the point is also on the plane. Okay. This is actually part 1 of question 6. In part 2 of question 6, what you're told is, now the value of m is 6. So if the value of m is 6, then you don't have a scenario where the line lies in the plane. Right? If m is 6, you therefore can imagine that the scenario will be like this, that this is the plane pi and this is the line L. Okay? That the plane pi and the line L are just parallel to each other, and the line L doesn't lie in the plane pi. So something like this, right? I can draw my diagram like this, or I could actually imagine that the plane from far, okay, it looks like a straight edge. But maybe I draw it slightly thicker because the plane, to distinguish plane and line, I will draw some slightly thicker and call this pi. So from far, when the line is parallel to the plane, from far I could draw them just like this. Okay, from far. So now in this question, given that the line L does not lie on the plane pi, you are asked to find the shortest distance between the line L and the plane pi. So you are asked to find this distance. Right. To find the distance from a line to a plane, given that they don't meet, is the same as finding the distance of a point on this line to the plane. Agree with me? To find the shorter distance from a line, to a plane is just the same as the distance from a point on the line to the plane, right? So this question reduces to just finding the distance from a point L to the plane pi. So do you have a point on the line L? The point on the line L in this case, right, because m is 6, right? Because m is 6, this point could be conveniently chosen as 6 minus 1, 0. So now to find the distance between the line and the plane, I simply find the distance from the point on my line L to the plane. And how do you find the distance from a point to a plane? Do you remember how? Like the earlier example, take the point in question, dot product with the normal of the plane, minus 1. Where does this 1 come from? This 1 is actually from here, from right hand side here. And then you divide it by the magnitude of the normal vector of the plane pi. So this is actually 1 plus 4 plus 4. So now you perform the arithmetic. You get for the dot product, right? For the dot product, you have 6 minus 2, which is 4. 4 minus 1 is 3. 3 over 3 is 1. So the distance from the line L to the plane in this case works out to be 1. Then let's do part 3. Part 3. In part 3, you are told that this time around you're not given a value of m, but you're told that the line L has a distance of 7 to the plane pi. So in part 3, what you're saying here is, if this is the line, then and this is the plane, right? This is the plane pi. Obviously, they are non-intersecting. Okay, line L must be parallel to plane pi to talk about certain distance. In this case, this distance is given to be 7. This distance is given to be 7. So now again, the subject is about the distance from a line to a plane. The distance from a line to a plane, as we have discussed in the earlier part, is the same as the distance from a point on the line. In this case, the point on the line is m minus 1, 0. Right? To say that the distance from line L to the plane is 7 is the same as saying that the distance from this point on the line L to the plane is also 7. So what it means is the distance from this point to this plane is 7. So what this means is I can now construct an equation. What's the equation I construct? Using the distance from a point to a plane, I can say that m minus 1, 0 dot with the normal of the plane, which is 1, 2, 2 minus 1 divided by the magnitude of the normal vector. This is actually the distance from the point to a plane. In this case, we are told that this distance is 7. Okay, now from this, I intend to solve for the value of m. So on the numerator, I will get m minus 3 modulus is equals to 21. So m minus 3 is equals to plus minus 21. So m is equals to 24 or minus 18. And that completes question number 6. In question number 7, you are given the equation of two lines and a plane, right? L1, L2, and then the plane pi. In 7 part 1, you are asked to find the angle between the line L1 and the plane. To find the angle between a line and a plane, I suggested to you in the lesson that you can start off with sine theta equals to you take the directional vector of the line and you work this together with the normal vector of the plane. So this gives you 1, 3 minus 2 dot with 3, 2, 1 divided by what? The magnitude of 1, 3 minus 2, which is square root 14, and the magnitude of this. As I told you also in the earlier lessons, that to find the angle between a line and a plane, by default it must be the acute angle. So in order to get the acute angle, you must always take the modulus, right? Just make sure that you get the acute angle, right? So now I'm going to perform the arithmetic. On the numerator, I'm going to get 3, 6, 9, 9 minus 2 is 7. So 7, 14, this gives you a value of half. So for sine of an angle to be half, the angle is 30 degrees, or you can write as pi over 6 radians. Right, so this is actually part 1, to find the angle between the line L1 and the plane pi. So bear in mind, to find angle between line and plane, I would suggest you start with sine theta, right? This is something that's slightly different from angle between two lines or angle between two planes, like slightly different. Part 2. For part 2, you're told that the angle between L2 and the plane is 60 degrees. L2 and the plane, right? To find angle between L2 and the plane, what we use is sine of, sine angle is 60, in this case 60, right? It's equals to, take L2, which is m5 minus 1 dot with 3, 2, 1 modulus divided by what? The magnitude of this vector and the magnitude of this vector. This gives you 26 plus m square, and this gives you square root 14. How much is sine of 60? Sine 60 is root 3 over 2. And then for the numerator, you're going to get 3m plus 9. This gives you right. So from here, in order to solve for m, I intend to actually square both sides, okay? So that I can remove all the square roots. So upon squaring both sides, I'm going to get 3, 14, 26 plus m squared. On the other side, I'm going to get 4 into 3m plus 9 squared. Okay? From here, I intend to solve for your m. Okay, so what I'm going to do is, so I'm going to just expand 3 times 14 times 26. Okay, so maybe we do our arithmetic a bit cleaner. I'm going to write this thing as cancel 3. I'm going to divide by 3 and divide by 2. Okay, I'm going to divide by 6 both sides. Okay, when I divide by 6 both sides, I'm going to get 7. 26 plus m squared. This is going to be 2. Then this one, I'm going to expand this. 3m squared plus 18m. Okay, let me see. 2 times 3, 6. Okay, then 81 is 27. Okay, just be sure, okay? I divide by 9m squared, 6 times 9 by 3, nice, 81. Okay, then should be correct, alright? So from here, I'll then have, it's just arithmetic, you can do it your way, okay? You can do it your way. It doesn't matter, you don't have to follow mine strictly. This gives you minus 36m, and then I will have 26 times 7, 54, 128. 128 equals 0. And then from there, you want to solve for, okay, this gives you, you can factorize this as m minus 4, m minus 32. So therefore, m is equals to 4 or 32. Right? This is actually 7 part 2. Now onto the optional question. Optional question. Onto the optional questions. Part A. Right, part A, you're asked to consider the dot product. Okay, part A, right? In part A, if you have a vector A dot with a vector B, by definition is magnitude A, magnitude B, cos theta. But because cosine theta is between minus 1 and 1, right? Because this is between minus 1 and 1, okay, maybe before that, I'm going to actually square both sides, okay? I intend to square both sides first. I will square both sides first. Square both sides, I get this thing square plus this thing square and cos. Okay, that's better. Right. So after squaring both sides, it becomes easier now. Since cos theta is between minus 1 and 1, so cosine square will be between 0 and 1. That means it's a fraction, right? 0 to 1, a number that is between 0 to 1. If this number is between 0 to 1, at the most 1, this entire arithmetic, right? This entire thing will be smaller or equals to this. Let me say once more, okay? Because this number is between 0 and 1, so this entire expression will be at most this number. Can you imagine if cos square theta is 8 over 9? 8 over 9 of this whole chunk is definitely smaller than this thing, right? And what it means is a dot b square will therefore be smaller than or equal to this, right? This green color. And this green color is exactly the statement that is given in the question. This left hand side, right? This left hand side is actually like this, no? It's actually a1, b1 plus a2, b2 plus a3, b3 squared. You see? And then on the right hand side, the magnitude of a square would be a1 square plus a2 square plus a3 square. And this one, again, the magnitude of b would be b1 square plus b2 square plus b3 square. And there you are, you have proven the optional question, part A. As I'm erasing the board, can you look at the part B, optional question part B. In optional question part B, you want to realize that they are talking about another inequality, and the question suggested that you should use the cross product. So I'm going to do part B here, part B. Right, part B. So you want to use the cross product this time. So cross product of two vectors A cross B by definition is modulus A magnitude B sine of an angle and then n cap. Right. So like the other question, we are also going to square both sides. Okay, we're going to square both sides. This gives you modulus of A cross B square equals to okay, I'm going to get sine square theta, and then this one will become magnitude square. Okay, so say once more again. After you have this line, after having this line, right, you actually magnitude both sides first. You take the magnitude of both sides first, and then you square it. Okay, so maybe it's bad I write this. Okay, maybe I should rewrite this. I should write this. I should say like this. I should actually say that I would take the magnitude on both sides first. I would take the magnitude of both sides first. Right, I take the magnitude of both sides first, right? Then after that I square both sides. Okay, I think that one is easier. So on the left hand side, I will have A cross B squared. And now you have the magnitude of a vector square. So become magnitude of A squared, magnitude of B squared. You got sine square theta. And then left with the magnitude of n cap square. Okay, magnitude of n cap we know is 1, so this thing will just be 1. And sine square, just like the cos square, sine square ranges from 0 to 1. So therefore I can say that this one will be lesser than or equals to magnitude A square magnitude B square. What I'm trying to say therefore is I will have this inequality magnitude of A cross B squared. So on the left hand side, right, the magnitude of A cross B squared. A cross B, if you could recall, right, A cross B, if you apply the, do you remember? A cross B, if you apply the approach, close the first row, find the determinant, close the second row, find the determinant, you find that A cross B will be just like this now. Will be just like this. A1, B2, sorry. Okay, if you cross product these two vectors, right? If you cross product A and B, let me write here. If you cross product A and B, which is A1, A2, A3, cross product with B1, B2, and B3. If you cover the first row, right? If you cover first row, you're going to get A2, B3 minus A3, B2. So the left hand side is actually a vector that's like this. A2, B3 minus A3, B2. A3, B2. And then we close the second row. A1, B3. A1, B3 minus A3, B1. But because the middle row need extra minus, this is as good as A3, B1, minus A1, B3. Right? I've already incorporated the minus sign. Then the third row will be A1, B2, minus A2, B1. Right. So if you look carefully, this left hand side, right, which is the square of this magnitude, it becomes the square of this magnitude, and the magnitude of this vector is this thing square plus this thing square plus this thing square, and then square rooted. Of course, with the square, you don't need to square anymore. So this left hand side is exactly what is needed on the left hand side of the required proof. So if I may write here again, this one, right? This one, if I may write here, this one is exactly the same as A2B3 minus A3B2 square plus A3B1 minus A1B3 squared plus the last one is A1B2 minus A2B1 squared. Okay, let me just check it. Yeah, can. Right, so this one is already the left hand side. This one is really left hand side of the required proof. And then the right hand side is the square, sorry, this one will be the A1 square plus A2 square plus A3 square. And then this one will be the B1 square plus a B2 square plus a B3 square. And then you're done with the proof. And that completes the optional questions.